All right, so now we're going to look at graphing rational functions. So we talked about looking at the vertical asymptotes, the domain, and the horizontal asymptotes. So looking at page 12, we're going to kind of combine that all together, add in a couple of things, and do our graphs. Okay. So I went ahead and gave you the strategies and the steps that your book provides you. Okay, that way you kind of had something to refer back to. So the following strategy can be used to the graph f of x equals p of x divided by q of x, where p and q are polynomial functions with no common factors. So it's already simplified. So first thing we want to determine is if you have any symmetry. And the key thing there, remember, we're looking at our exponents, or you can plug in negative x, okay? And we'll go over both of those. Second, we want to find our y-intercept. Then we're going to find our x-intercepts. With that, we're just going to look at our numerator. Okay, our numerator is going to tell us our x-intercepts, where our denominator is going to tell us our vertical asymptotes. We're going to use our degrees to find our horizontal asymptotes. And then we're going to plot points. Okay. All right, so look at this first one. Graph f of x equals 2x minus 1 divided by x minus 1. So we're going to review some symmetry here. So first step, looking at symmetry. Okay, we're going to go ahead and plug in f of negative x. So this is one of our methods we can use. So if we plug that in, we have 2 times negative x minus 1 over negative x minus 1. We want to simplify and see if we get back what we started with. Okay. Well, 2 times negative x is a negative 2x minus 1 over negative x minus 1. Well, that's not our original function. Do we agree? Okay. Well, let's see if we divide everything by a negative 1. Divide by negative 1, we would get 2x plus 1 over x plus 1. Is that what we started with? No. So that means we have no symmetry. Okay. All right, second step, we want to find our y-intercept. And the way we find our y-intercept is we look at finding f of 0, meaning we just plug in 0 for our x's. So we have 2 times 0 minus 1 over 0 minus 1. Well, what's 2 times 0? 0. So we have negative 1 over negative 1, which equals 1. Okay. A shortcut you can use is just look at your constant on the top and the bottom. Okay, negative 1 divided by negative 1. So our y-intercept is 0, 1. And I'm just going to highlight that and we'll come back to it. Okay, we're going to find everything and then we'll plot it. All right, so third, our x-intercepts. And we're going to set our numerator equal to 0. So 2x minus 1 equals 0. Well, then what does x equal? 1/2. So we have the ordered pair 1/2, 0. Okay. Step 4, we want to find our vertical asymptotes. Well, vertical asymptotes is when we look at our denominator. So I'm going to say x minus 1 equals 0, which tells us that x equals what? Positive 1. And that's our vertical asymptote. And then the horizontal asymptote. We're looking at the degree of our numerator and the degree of our denominator. So, what is the degree of your numerator? 1. And the degree of our denominator? 1. Well, those two are equal to each other. And if they're equal to each other, what's our rule for our horizontal asymptote? What do we look at? We divide. So we're going to use our leading coefficients. So it becomes y equals. So the leading coefficient of our numerator is 2. And the leading coefficient of our denominator is 1. And 2 divided by 1? 2. So y equals 2 is our horizontal asymptote. Right? Questions with finding any of those 5 things? All right, so now we're going to graph it all. Okay. I recommend that you always start with your asymptotes first. So our vertical asymptote, x equals 1. Make a dashed line. And then we have our horizontal asymptote at 2. Okay. All right, we good with that? Okay, now plot your points that you know. We have a y-intercept of 1. And we have an x-intercept of a half. All right. All right, so now we need to sketch our graph. Here's the thing. You're never going to cross a dashed line, because that's the rule we're going to go with for right now. And you can only go through your x or y axis through a point. Okay, so based off of that, we know we have to go like that. That's the only place we can move. And we can't cross anything. So that means to the left, we're going to keep getting closer and closer to y equals 2, but we're never going to cross it. And then as x approaches 1, we're going to get closer to negative infinity. Okay. And now we need to figure out what happens on the right-hand side. Okay. So we can either graph here or here. Right? Do you agree with that? Top or bottom? Okay. Here's the problem. Don't write this down. Can we sketch our graph like this? Can we go through that x-axis? Why not? You're right. But why can't we go through it? There's not an x-intercept there. Yes, correct. Okay. So we can't graph that there. So instead, we have to jump up to the top. Okay. So there's a little trick I'm going to show you guys, or tell you about. And we're going to talk about our multiplicity. Remember, if multiplicity was odd, we did one thing. If it was even, we did another. That same thing applies to our asymptotes. Okay, so looking back at our vertical asymptote, we found x equals 1. How many times did that occur in our denominator? Once. So I'm going to come down here and say multiplicity 1. Okay. So our multiplicity for our vertical asymptote is 1, which means it's going to jump to the other side. Meaning bottom to top. Okay, it could also go the other direction. It could go from the top down to the bottom. If you have a multiplicity of 2 or even, it's going to volcano. That's what I call it. And we'll talk a little bit more about that in a bit. Okay. That idea of multiplicity also holds true for your x-intercepts. Remember, if we had multiplicity odd, which is what we have here, we cross through. Well, look at your graph. At that x equals 1/2, did you cross through the x-axis or did you bounce back? We crossed through. Okay. So that's something that can help you connect everything together. Questions? I'm gonna try another one. Okay. Next page. And I know I gave you a ton of room on these, but I just wanted you guys to have extra room to write if you need it. Okay. All right. F of x equals 3x squared divided by x squared minus 4. So first thing, let's look at symmetry. Okay, you can use either the f of negative x, which let's just keep doing that. So if we plug that in, we have 3 times negative x squared divided by negative x squared minus 4. Well, if we square a negative, it becomes positive. So this becomes 3x squared over x squared minus 4. What do you notice? It's the same. So this is the same as f of x, which means it is even. And if it's even, it's symmetric. Across the y-axis. Symmetric across the y-axis. Yeah.
Isn't there also a trick where you can just use the exponent?
Yep, so that's where we're going. So now if you look back at these exponents, we had 3x squared, x squared, and minus 4. Remember, when we have that minus 4, that's like x to the 0 power. So 2, 2, and 0, those are all considered even when we're graphing. So we know it's an even function. So you could just look at your degrees. Okay. If the exponent thing doesn't make sense, do the negative x. That will always work. Okay. All right. So now let's find our y-intercept. So our y-intercept is when we plug in 0. So f of 0 equals 3 times 0 squared over 0 squared minus 4. Well, what do you get in your numerator? 0. And what's 0 divided by negative 4? 0. So our y-intercept is the ordered pair 0, 0. Okay. Third, let's find our x-intercept. That's when we set our numerator equal to 0. So 3x squared equals 0. Well, how would we solve for x? Divide by 3. So x squared equals 0, which means x equals 0. But since it's squared, what could we say? How many times is that x equals 0 going to actually appear? Twice. So let's write in a multiplicity of 2. And when we have a multiplicity of 2, what happens? It bounces back. That rule still applies when we're graphing a rational expression. Okay. All right. Vertical asymptote. So vertical asymptote, we're gonna look at our denominator. So if x squared minus 4 equals 0, so you can either solve this with square roots or by factoring. Which one do you want to do? Factoring. Okay, so x squared minus 4, that becomes x plus 2 times x minus 2 equals 0. So what does x equal? Good, so x equals -2, x equals 2. And just since we've been talking about, what's the multiplicity of each of those? Just 1. Okay, so there's a 1 outside of both of these parentheses, which means our multiplicity is 1. Okay. And I'm going to go to the right. So step 5, our horizontal asymptote. What's the degree of our numerator? 2. What's the degree of our denominator? 2. And if those are equal, we look at our leading coefficients. So y equals, what's the leading coefficient of your numerator? 3. And the leading coefficient of your denominator? So y equals 3 is your horizontal asymptote. Questions with finding any of those 5 things? Okay, let's throw it up on that graph. Okay, so I always start with asymptotes. So we have vertical asymptote at -2 and at +2. And then a horizontal asymptote at 3. Okay. Well, the only point we have is 0, 0. Okay, so let's start where that point's at for our graph. Can we, and don't draw anything yet, can we go up like this? Can you cross that horizontal axis? Or not axis, how about asymptote? No. Okay. And I should have made that a solid line. Okay. So that means we have to go down and back. Why are we going up and then back down? Because the multiplicity was 2. So that's the reason why we're able to bounce back. M2, bounce back. That's why we're able to do that. Okay. Now looking at our asymptotes, what were our multiplicities on both of them? 1. So that means, I'm going to start over here on the right. We were on the bottom. Multiplicity is 1, so we're going to jump up to the top and swoop over. And then same thing on the left. We're on the bottom. The multiplicity is 1, so we're going to jump up to the top.
I don't understand.
It's just a rule. Because, okay, well, here's the other thing. Here's why you couldn't go here. If you went up here, can you cross that x-axis? So you can't do that because of the fact that you don't have any x-intercepts. So that kind of locks you into only being able to graph your function up here. Same thing on this side, you don't have any x-intercepts to cross, which forces you to graph your function up here.
But why do we have 3 of them on this one?
Because we have 2 asymptotes here. So it breaks it into 3 sections of your graph. Okay, other questions? All right, let's do the last one. Okay. All right, so first off, symmetry. Okay, let's use our exponent rule. What are our exponents on these? 4, 2, and 0. Those are all even, which means we're symmetric across the y-axis. And actually, since I just brought up y-axis symmetry, I'm going to slide this back up. If you look at this graph, we're symmetric across that y-axis. Okay, so that's another reason why you have 3. Okay. All right. And since I just drew that, I'm going to go ahead and draw that again over here. There. Okay. Next, we need to find, what is it, our y-intercept? So if we find f of 0, we get 0 to the 4th over 0 squared plus 1. Well, what does that equal? 0. Third step, we need to find our x-intercept by setting our numerator equal to 0. So if x to the 4th equals 0, what does x equal? 0. With a multiplicity of 4. Which means it's going to do what at the x-axis? It's even, so it's going to bounce back. Okay. The only difference between it and the squared degree is it's going to be a little bit flatter of a bounce back. Okay. All right. Vertical asymptote. So we have x squared plus 1 equals 0. Subtract 1. So if x squared equals -1, what happens when we take that square root? We get I. Can we graph I? So there are none. There are no vertical asymptotes. So that makes it a little easier. All right, 5 are horizontal asymptotes. So what's the degree of your numerator? 4. And what's the degree of your denominator? 2. All right, when the degree of the numerator is greater than the degree of the denominator, what's your horizontal asymptote? Nope. Nope. None. We're going to talk on Monday what happens when it's a difference of 1. Okay, so if this was 3 and 2, we have a new asymptote that we'll talk about later. Okay. All right, well, the only thing we can really graph here is 0, 0. All right, this is where you could then plug in points. Okay, but what's going to happen with this, it's just going to be a very wide parabola. It gets really close to the x-axis when it touches the x-axis. And that's it. There are no asymptotes. There's no dashed lines. It's just a really wide parabola. Okay, so your homework today is just graphing. But here's what I recommend. You're going to have to find these 5 steps, and then it's just going to be multiple choice. Okay? There's a very good chance I'm going to make you graph it by hand at some point. So I would practice that. Okay? It also will help you make sure you understand which graph you're multiple choicing. Okay? All right.